problem y equals x to the fourth minus 3x to the third plus 3x squared minus x, we are asked to sketch the curve using the guidelines from section 4.5. And since it's a polynomial, that means the domain is all real numbers. Negative infinity to positive infinity. And then we got to find the y-intercept and the x-intercept. We'll start out with the x-intercept first, which y equals 0. So 0 equals x to the fourth minus 3x to the third plus 3x squared minus x. So it's not as simple as it looks, but I end up breaking it down into x squared minus 1 times the quantity of x to the third minus 2x squared plus 1, which ends up giving us the intercepts 1 and 0. And now we gotta find the y-intercept, which x equals 0. You just simply plug in 0 into the original equation. 0 to the fourth minus 3 times 0 to the third plus 3 times 0 squared minus 0 ends up giving us 0. So now we have to find if they have horizontal asymptotes, in which it actually ends up not having any. So then we want to make a line to see where it is positive and negative, which ends up telling us where the graph is increasing and decreasing. So I use all the answers for that. -1, 0, and 1. And then I use those, when I broke this down into, I plugged that into these margins. x3 minus 2x squared plus 1, x squared minus 1. So we gotta plug any number less than -1 and plug it into these equations. Any number in between that, which I actually used 1/4 for that. -1/4, 1/4 for this. Just put that right there. And I'll just use -2 for this one and 2 for that one. And you end up getting a negative here, positive, positive, positive. Then for this one, you end up getting positive, negative, negative, positive. So now we gotta draw a line for the function. Negative times a positive gives us a negative, 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 positive. So on the interval, it is decreasing on the interval negative infinity to 1/4, and then it's increasing on the interval from 1/4 to positive infinity. Okay, now we gotta use the first derivative test. We find the first derivative of the original equation, which gives us 4x to the third minus 9x squared plus 6x minus 1. We know that this does not exist, isn't possible here. And I did the same thing I did for the last problem, because it's not a simple quadratic. So I used the rational root theorem, and I ended up getting x minus 1 times 4x squared minus 5x plus 1, which gives us x equals 1. And then breaking this down with the quadratic formula, I got x equals 1 for that and 1/4. And now using the number line for this, plug in the x minus 1, 4x minus 1, because this breaks down to x minus 1 times 4x minus 1. We don't have to use x minus 1 twice because it comes in. So we just plug in x minus 1 and 4x minus 1 for our margins. And for the number line, 1/4 and 1. So now you got to pick any number less than 1/4 and a number between 1/4 and 1/2, which I used, or 1, which I used 1/2, and then I used 2 for this one, -1 for this one. You end up getting negative, negative, positive, and then for this one you end up getting negative, positive, positive. Now putting it on a line to see where it's increasing and decreasing. We get actually, yeah, so negative times a negative equals a positive, negative, positive. Show this like this. We see that it's increasing on the margin, negative infinity to 1/4, and also from 1 to positive infinity, and then it is decreasing on the interval, as you can see, 1/4 to 1. And as you can see from this, that there is a local minimum. So now we got to define that. And I plug, which the local min is actually at 1/4. So we plug in the 1/4 to the original equation. 1/4 to the 4th power minus 3 times 1/4. And then through this, we actually end up getting negative 27 over 256. So our local min is actually, well, put this in simpler terms, function of at 1/4, negative 27th of 256. That's our local min. And that's all you can get out of that, actually. So now for the second derivative, you find the derivative of your last equation, which ends up giving you 12x squared minus 18x plus 6. And I factor out a 2 in this, which gives us 2 times x squared minus 9x plus 3. X minus 1, which ends up, yeah, that's what ends up breaking down to, and which gives us x equals 1 times 1/2. So once again we do a number line for this, plug in x minus 1, 2x minus 1, 1/2, 1, pick a number smaller than 1/2, which I could pick negative 1 in between 1/2 and 1/4. Pick 3/4, and then 1 or 2. You end up getting positive, 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 and then for 2x minus 1, you get negative. Actually, this is actually a negative. So is this. And that, and that's a positive, negative, positive, positive. Now for the second derivative line, actually I left something out on accident. You gotta add the 2 there, and obviously the 2 will produce all positives. So positive times a positive, positive times a negative is a negative, times another negative is a positive. A positive times a negative times a positive is a negative. then we end up getting a positive here. So you can see the function is concave, up, down, up. It's concave up from negative infinity to 1/2, and from 1 to positive infinity, and then it's concave down. It's in the margin 1/2 to 1. And from this we can find a point of inflection in here, which is actually, 1/2 and 1. Plug those into our original equation. X equals 1/2. 1/2 to the 4th power minus 3 times 1/2 to the 3rd power plus 3 times 1/2 squared minus 1/2 ends up giving us the point 1/2 negative 1/16. Then we do the same exact process for 1. Get 1 here plus 3, 1 minus 3 actually, plus 3 minus 1, you get 0. So that point is 1, 0. Now after combining everything, you can actually sketch the graph of the function, which ends up looking like I need to find a blank piece of paper. It ends up looking like something like this. And it dips here, and then it goes back up at 1.